in case you're wondering why I chose to multiply by 360 over 15 pi, since we're trying to get theta by itself, and the 15 pi is in the numerator, I had to put the 15 pi in the denominator so that it would cancel. And because there's a 360 in the denominator, I had to put it in the numerator so that they would cancel. And I would just be left with theta. On the right side, the pi's cancel. And then I'm just going to go ahead and put into my calculator 7 times 360. And then I'm going to divide it by, in parentheses, 2 times 15. And I get 84 degrees. So theta is 84 degrees. All right, let's go on to the next problem. The circumference is 22 pi, and the length of the arc is 17 pi over 2. Find the subtended angle. Let's remember again that we have our fraction of the circle times our circumference equals our arc length. And I'm going to draw a picture. I've got my length of my arc right here. I'm going to highlight this one. This right here is 17 pi over 2. And the entire circumference is 22 pi. This is probably not a real accurate picture, but that's okay. Fraction of the circle, I don't know what my angle is, so that's my theta, divided by 360 degrees, times my circumference, which is 22 pi, equals 17 pi over 2. Now, I'm trying to get theta alone, so I need to multiply by 360 in the numerator to get the 360s to cancel, and 22 pi in the denominator to get my 22 pi's to cancel. And I have to do the same thing on the other side. So theta equals, again, my pi's are going to cancel. And then in my calculator, I'm going to take 17 times 360 and then divide by 2 times 22, I know is 44. And I get 139.1 degrees approximately. All right, let's go to our next one. Circumference is 7 pi, and the length of the arc is 1.5 pi. Find the subtended angle. Again, I have my fraction of the circle times my circumference equals my arc length. My fraction of the circle, I don't know my angle. Let's go ahead and draw our picture. I know that this length of the arc is 1.5 pi. I don't know the angle. That's what I'm looking for. That's my theta over 360 times my circumference, which is 7 pi, equals my arc length, which is 1.5 pi. Again, I'm trying to solve for theta, so I need to do the 360 in the numerator to get those to cancel, and the 7 pi in the denominator to get the 7 pi's to cancel. And that means I have to do the same thing on the other side. 360 divided by 7 pi. The 360s and the 7 pi's cancel, and I get that theta equals, the pi's cancel. In my calculator, I'm going to do 1 0.5 times 360, and then I'm going to divide by 7. And I get approximately 77.14 degrees. So that's what that angle would be. Right, so let's do our arc length and subtended angles practice. A circle has a circumference of 6 units and a central angle of 60 degrees. What is the length of the arc? I like to draw a picture. I'm a very visual learner, so a picture helps me. Got a central angle of, let's say, 60 degrees. And the circumference is 6 units. And I'm looking for the length of the arc. That's what I don't know. Again, every time, fraction of the circle times the circumference equals the arc length. I know my fraction this time. It's 60 out of 360 times my circumference is 6 units equals, that's going to give me the length of my arc. So I'm going to actually end up with 360 over 360, which is simply 1 unit. So this would be 1 unit, which makes sense. It's 1/6 of 6, which is 1. All right, let's look at number 2. We are asked to find the length of arc DC. This right here. Well, I know that I need a fraction of my circle times my circumference equals my arc length. Well, in geometry you should have learned that if this is 60 degrees, this angle here must also be 60 degrees. They're vertical angles. You also should have learned in geometry that when you have a straight line, this is the diameter of the circle, a straight line is 180 degrees, so if this is 60, this must be 120, which also makes this 120. Well, I know then the angle that goes with this arc, it's 120 out of 360 times the circumference. Do I know the circumference of my circle? All right. Now, the circumference of the circle, this was supposed to have been given to you, that the length of PB is 8. And we should see that this is a radius of the circle, and circumference equals 2 pi r, which would be 2 pi times 8, or 16 pi. So 16 pi is the circumference. That is going to give me my arc length. So using my calculator, I'm going to take 120 times 16 and then divide by 360, and I get 5.3 repeating pi. If I want to multiply that out, my arc length is approximately 16.755. So I could write it either way. And the 5 1/3, if I wanted to change that, that could be 16/3 pi, is another way to have written that. Which makes sense. If it was 16/3 pi, 16 pi is the entire circumference, and this is 1/3, 16/3. All right, let's go to number 3. This time I have everything labeled the way I should. I didn't forget anything. What is the length of arc A, B, C. So I'm going to go, this is a major arc then, not a minor arc. And I want to know the length of that arc. Again, it's the length of an arc is always fraction of the circle times the circumference equals arc length. My fraction of the circle, I've got 111, and I have 129 degrees, or 240 degrees then. 240 degrees out of 360 times the circumference. Again, I know my radius, which is 6, so circumference equals 2 pi r, so it equals 2 pi times 6, which is 12 pi. Let's see what I'm going to get for that. I have 240 times 12 divided by 360, and that's 8 pi, which I want to show you why that makes sense. This 240 out of 360 I could divide by 10, and 24 out of 36, they can both be divisible by 6, which is by 12 actually, 12, which gives me 2/3, and 2/3 of 12 is 8, so 8 pi. All right, let's go to our next problem. What is the length of major arc ACD? That tells me that I'm going to go all the way around like this. A, then C, then D. All right. So to go from A to C to D, I'm doing the entire circle except for this 35 degrees. That's the only part I'm not doing. So everything else is part of this arc. So I know that I'm just, this entire angle here is just 360 degrees minus 35 degrees. Which is 325 degrees. So again, to find my arc length, I want fraction of the circle times circumference equals arc length. My fraction is 325 out of 360 degrees. My circumference is 2 pi r, and my radius is 3. So I'm going to have 2 times pi times 3, or 6 pi. 6 pi, that's going to give me my arc length. So I take 325 times 6, and then I divide by 360, and I get 5.42 pi. Let's see if there's a fraction for that. Math, enter, enter. 65/12 pi. I think I'll just leave it as 5.42 pi. Right, number 5. What is the length of arc BC? Right. Well, this angle here is 152 degrees, and if you'll see, the markings on here means that these angles are the same. So I need to figure out what they would be. So I'm going to start by saying 360 degrees minus the 152. And I'll get that 308 degrees is all of this. Well, if these two angles are the same, it just must be 308 divided by 2, which would be 100